Hi everyone. In today's lesson, we're going to learn about a theorem called the intermediate value theorem. So the intermediate value theorem, or IVT for short, states if a function f of x is continuous function over the interval from a to b, then there exists at least one c in between the interval of a to b, such that f of c is also between f of a and f of b. So I know that's a mouthful, so I kind of want to give you an example of what it looks like. So let's just say we have an interval from A to B. So usually intervals are x-axis values, right? An interval from say 2 to 7, for whatever number you want to make it. So what the theorem states is that for when A is, let's put up here f of A, and let's put up here f of B. So basically what I'm saying is when A corresponds with f of A, right, that's a point x comma y. X is your A value, y is your f of A value. And B corresponds with f of B, so we have B as my x value and f of B as my y value. And let's just say it's a curvy function that's connected between these two. So f of x is a continuous function over the interval from a to b. I don't have to pick up my pencil, so it's continuous. Then there is going to exist one c value in between a and b, such that f of c, so let's just say f of c is here, that is also going to be in between f of a and f of b. So, I mean, that kind of makes sense, right? This is your other point, c, comma, f of c. So if I have a continuous function in this scenario, where I have a and b, the endpoints of the interval, there is going to be a c value such that f of c will be in between the given two y values. Now this will also work when f of a is greater than f of b. So let's just say we still have that interval over a to b, but now this time f of a is greater than f of b. So if we connect the points, here is your first point, a comma f of a, and down here is another point, b comma f of b, and say I connected these two, there's still going to be a c value in between the two, such that f of c will be in between a and b. I mean, technically the way I'm drawing it's f of c should really be all the way down here, so you can kind of move that and fix it, but that would be your next point in the middle. Now, this theorem might sound a little almost like common sense, and it kind of is. So we're going to show you some applications that you can use with this theorem. So first, a visual representation of the intermediate value theorem. So the graph of f of x is given below here. So there's two questions that I want to ask you. Between which two x values does the function have a positive, zero, root, or solution? And explain why. So I'm looking for a positive zero, root, or solution. So positive. So we're going to look on the positive side of the x-axis, and we're going to look to see where it crosses. So it clearly crosses here at x equals 2. So in between which two x values does this happen? Well, it's going to happen between the x value of 1 and the x value of 3. So we could write x equals 1 and x equals 3. So we can use the intermediate value theorem to prove the existence of this root. So what we're going to do is we're going to find f of 1, and we're going to find f of 3. So here is your original function. So if I want to find f of 1, that just means everywhere I see an x, I'm going to put a 1. Again, using the function up here, if I want to find f of 3, that just means everywhere I see an x, I'm going to put a 3. So take a minute, pause the video, and calculate these two values. Okay, so f of 1 should be -4, and f of 3 is 18. So you could probably see a couple of those values with the graph here. So f of 1 we definitely see is -4. And I know this one is off the graph for 3, but that would be probably somewhere up here. Let's call this 18. So if this is your continuous function from here to here, right? Here's your interval over a to b. There exists some c value, which we'll call here in the middle, some c value such that it's between, if this is your f of a, y value, and this is your f of b, y value, there's an f of c right here in the middle. So the c value would be 2, such that the f of c is between these. So this works. That is your intermediate value theorem. So what you could say, since f of 1 is -4 and f of 3 is +18, f of 2, the x value at 2, must be between y equals -4 and y equals 18, which it is. The y value, f of c, or f of 2, is 0. So we could even say that. F of 2 equals 0 must be between y equals -4 and y equals 18. All right, let's try example number 1. So without a picture, this is how they'll ask you to use the intermediate value theorem. So they'll say, explain why the function f of x must have a root on the interval from -1 to 3. So this is your a and this is your b. So what we're going to do, same thing as before, we're going to plug in f of -1 and f of 3. So -1 squared minus 4 and 3 squared minus 4. So the top one is going to be -3 and the bottom one is going to be 5. So if the intermediate value theorem is true, using the intermediate value theorem, right? This is your a value, your interval is from a to b, and your interval is -1 to 3. So you could say, since f of -1 is -3 and f of 3 is 5, there must exist an f of c value that is in between y equals -3 and y equals 5. So a root of y equals 0 would totally fall into this. So a root of y equals 0 is in between the y value of -3 and a y value of 5. So just to give you a graphical idea of what's happening here, if you were to graph this, f of -1 is -3, so that would be that down here somewhere. F of 3 is 5, so that would be up here somewhere. And if we connect these two, right, this would be your continuous function. So there must exist a c value in between, let's call this the c value, such that we have a root. So it's obvious, if we're going from negative territory to positive territory, I'm going to have to cross the x-axis at some point. So therefore the root would exist. Okay, let's try example number 2. So verify the intermediate value theorem and then use that theorem to find c. So in this particular problem, they're giving you a specific y value that c should be. So the best way we can answer this is we need to say, well, this is the y value that this graph must hit. So what we're going to do is set the equation equal to the y value. So x to the third minus x squared plus x minus 2 must equal -1. And we're just going to factor and solve. So we're going to add 1 to both sides. We get x to the third minus x squared plus x minus 1 equals 0. And we can factor. Factor by grouping because we have 4 terms. So the GCF of the first 2 terms is an x squared, and I'm left with x minus 1. Bring down the sign in the middle. The GCF of the next two terms is just 1, so I'm left with x minus 1. And I have another x minus 1 in common, and x squared plus 1 equals 0. And all we have to do is do a t-chart to solve. So x minus 1 equals 0. We add 1 to both sides. We get x equals 1 over here. And when we do x squared plus 1 equals 0, we're going to subtract 1 on both sides. And when you do that, you get negative 1. And remember, if you try to take the square root of a negative number, you actually get plus or minus I. These are imaginary numbers. So remember that imaginary numbers never cross the x-axis. So what that'll mean is that we'll probably reject these because it's not going to be a value that we're going to use. So the actual answer here is going to be x equals 1. And you have to just check to see that it's in between the original interval. And that's true. 1 is definitely in between 0 and 3. So let's verify this with the intermediate value theorem just to show that our answer makes sense. So if we try to find f of 0 and f of 3, so let's use the original function, pause the video, and find these two values, and then hit resume when you're ready. Okay, so f of 0 is negative 2, and f of 3 is 19. So if we were to draw a sketch of just those values, so when x is 0, y is negative 2, so we could put a dot here, and when x is 3, we're at 19. So let's just say 19 is there. So your curve would look something like this. So the intermediate value theorem states that in between 0 and 3, there is going to exist a c value in the middle that will be at negative 1. So I want to find specifically at negative 1 what this c value is going to be, or what x value is that going to be. And doesn't it make sense that it could be 1, right? If this is 0 and this is 3, then this c value could absolutely equal 1. So the reason why we had to in the first place was set this negative 1 equal to this graph is because if this is the curve, I want to find an x value when y is negative 1. All right, last but not least is number 3. It says verify the intermediate value theorem and then use it to find c. So the first thing you should notice is that this is actually a rational function. And rational functions have holes and or vertical asymptotes. So if we factor the top, we get x plus 1, all I did was GCF, and the bottom is x minus 1. So since nothing cancels, that means we have no holes. But since we still have a denominator, you could set that equal to 0 and solve. So since you get x equals 1, this is a vertical asymptote. So let's just write down no holes because nothing canceled. And since there was something in the denominator, this is where the function is undefined, and that undefined value is a vertical asymptote. So what that means is that this function is not continuous. And you can say because of the vertical asymptote at x equals 1. So since the function is not continuous, the intermediate value theorem does not apply. And that's it, that's your answer. So since the function is not continuous, the intermediate value theorem does not apply. And the reason why is if you look at the definition of the intermediate value theorem, it says for a continuous function. So it's not continuous, therefore I can't apply it. All right, that's it for today. If you guys have any questions, now's a good time to jot them down, and I'll see you guys in class tomorrow. Have a good night.